Hello, very good morning to all of you students. How are you? I hope you all are happy, healthy and fine at home. What did we discuss yesterday? We discussed about the symmetry of the carbohydrate, how symmetry elements are important as far as the natural product is concerned, because we are talking about the Chiron approach and we are trying to find out in that we are learning the concept of chiral templates and chirons, wherein the carbon skeleton is the chiral precursor. We are importantly finding here what do you mean by chiron, what do you mean by the chiral templates, what do you mean by the chiral precursors, chiral means what, that we are trying to explain by taking different examples. So far we have seen different strategies, different approaches to synthesize, to arrive at that particular points. So today let us see as a design, because in the previous lecture I already told you about design, discovery and execution of this particular approach, and that is the today we are going to learn the concept of chiral templates and chirons, a visual dialogue with the targets. Means here the chiron is nothing but it involves the two terms together, and each it made, that is a chiron. Two term, what are those two terms? One is a chiral, and as we know that chiral is coming from the chirality. Chirality is very important as far as the controlled or stereo selective, or what we can call it as a chemoselective type of the term, stereo controlled functionality overlap, how we are correlating in particular synthesis of that carbohydrate that we are looking. So let us see how we can make strategy to synthesize that type of the natural product which are medicinally useful. Let us look at the definition of that chiral template we already learned. Let us see again the carbon framework, which are an exact copy of the segment of the target and have its inherent natural chirality, which can be related to original stereochemical part of the target, are called as a chiral template. A strategy that provide a particular approach to such a target is based on the concept of chiral templates and the generation of chirons, which represent enantiomer pure. Enantiomer, these are the words frequently, you are already familiar with these words, pure synthons, and in essence this involve scrutinizing the molecular architecture of given target to locate elements of symmetry, chirality and functionality, decoding such type of symmetry in the target molecule. We focus information and transposing it onto the carbon framework of the suitable synthetic precursor or chiron, which in turn are obtained from chiral starting material, means chiral templates. By systematic functionalization, the term chiral template derives its origin from the following consideration, and it is a template in the sense that the carbon framework is a replica of a segment of its inherent natural chirality, which can be related to the original stereochemical code of the targets, and mention should be made of the widely used term synthon, and as we know that synthon is associated with the polarity, and which is used in the retrosynthesis, introduced by Corey. Corey is again one more of the founder who first time innovative disconnection of the complex molecule, and it can be synthesized forward and reverse logical chemical reaction is known as a retrosynthetic and innovative. And when Corey he first announced his innovative strategy for the construction of complex molecules by considering retrosynthetic analysis, and unfortunately the term synthon, presently also referred to as a tetron, is sometimes loosely used to mean an intermediate, and this generalization deviates from the original designation, and in the original variation of the term was interchanged to describe an idealized fragment, usually carbonium ion or carbonium ion or the carbanion, or a synthetic equivalent produced by the bond disconnection during the retrosynthetic analysis. While studying that retrosynthetic analysis, because that approach here also we are going to use, and while studying that approach, what are the important term used in the retrosynthetic analysis, that also we are going to learn in short after some time. It may involve some simple starting material or reagent, and in the synthon based approach to organic synthesis, the strategy is based on bond disconnection according to the logical but not necessarily the most strategic site, which take into account stereochemical features, because in this particular we are going to disconnect the molecule via chiral to arrive at the chiral precursor or the chiral template, particularly for this Chiron approach. The reverse process, namely the synthesis of the segment in question, can therefore be complemented via an aldol condensation as depicted by the initial bond disconnection process, and with the obvious need to synthetic enantiomerically pure or enriched molecules, the synthon approach to this segment must make additional provision for stereochemical control, and this can be achieved by ensuring a measurement of stereo selection in the aldol condensation. Alternatively, we may choose to use optically active chiral starting material to construct the segment in question, and the Chiron strategy differ in concept is that strategic bond disconnection in the target molecule proceed by locating segments containing a number of chiral centers. Definition. Look at here the definition of the Chiron again. Chiron are then retrosynthetically generated by minimum perturbation of chiral center in the target is known as a chiron, and this chiron word itself involves the two terms, one is a chiral and second one is a synthon. The operational aspect of this strategy is systematically illustrated below by considering representatives of the 4 classes of chiral building block, which we already know that one is a carbohydrate, amino acids, carboxylic acids, and the terpenes. And we will deal primarily with the carbohydrate as a starting material and refer to the other as the disconnection one. The combination of natural chirality, conformational bias, and inherent topology in a carbohydrate combine to provide an ideal carbon framework or platform for achieving a high level of regio and stereo control. Hence, chiral and functional overlap with the chiron and ultimately with the strategy. Now let us look at how this terms, one is a chiral template and the chiron over here. Let us see here one more target molecules. Let us see, here is a 6-membered ring which is drawn over here. Let us see the carbon framework or the carbon skeleton. I am darkening these bonds so that you can easily recognize, or I am highlighting these bonds so that you can remember the carbon skeleton over here. Now this is the bond which is carbon skeleton I am showing over here, and then this side also, this one, then this side, and then will be this will be like this. Then this is our target, you can remember, target. This is a target, and this target have some substituent at the junction point, or here you can call it as a here is a B, then here is a C, here is a E, here is a, at this junction is a D. So this is a target. Let us see, because we are finding the chiron, what actually means. Now if you see reverse of this, or this first, let us see, this is a disconnection arrow. Disconnection arrow means it is an analytical operation to reach the reactant starting from the target molecule by using disconnection, and FGI is known as this one, that is a chiron. Over here we are going to get, let us see here, O, then this again is a 6-membered ring. That 6-membered ring I am again highlighting these bonds so that you can identify very easily the what kind of the chiral carbon framework present in the carbohydrate, which is X. Here you can call it as a, here is a B, and here is a C. So this is called as a chiron. This is known as a chiron, where the carbon skeleton is present in this case, or we can write this way. Again here is a D. Again I am highlighting this carbon skeleton like this. Here is a X, and this D. This is a chiral template. This is known as a chiral templates. This is known as a chiral template. Chiral template. Chiral template. This is known as a chiral template. right? This is a chiral template. This is a chiral, this is a target molecule, this is a chiral, and this is a chiral template. Chiral template is nothing but as a chiral precursors. So here we can show the carbon skeleton like this. This and this one, you can show the carbon skeleton like as a open chain type of the, here A, here is a C, and here maybe as a B. So this structure may be as a like this, or one way of representing one E skeleton, E subtotal, this E like this, and D may be as a here somewhere like this. I am showing that one. This is a D, and this transpose, and here you can write as a transpose like this. You can be get as a skeleton like this. There is a hydrogen atom, and here dot NH2, and here CO2H, and this side may be as a HS. As we know that systemic acid it is one of the amino acid, and then next maybe as a this one. I am again highlighting this bonds. So that is a carbon framework. Here OH, and here is a hydrogen atom CO2H, then CO2H. This is a, as we know that carboxylic acid, or this way you can show over here. This can be achieved from this bonds. Here you can show dotted is a Z group. Again I am highlighting this thick line clearly indicate that here you can write X, or here is a Y, and here is a B, here is a A, and here as we know that it is a C present, that one of the skeleton, or second one may be here. This is a E, or you can show here is a, again this is a D. So this you can show, or activate by activating this chiron, by activating this chiron will get this one, or sometime you can get this type of the structure over here, this one, that then maybe as a Me stand for as a methyl group. Hydrogen atom is above the group, and here is a OH, Ca2OH. This is a citral type of the compound, and next one maybe as a this one. As we know that this is one pyranose type of the ring, or which is a D glucose over here. Here is a HO, then here alpha glucose OH, and this OH, that we know that this is a glucose over there. Acyclic, these are acyclic equivalents. These are the acyclic equivalent, and this is all about the chiron and the chiral template. Look at, this is a target molecule, and as we know that target molecule means what? The molecule whose synthesis is being planned is known as a target molecule. And there after doing as a retrosynthesis means what? An imaginary but logical reverse chemical reaction which helps to reach the reactant starting from the target molecule is known as a retrosynthesis. And in that retrosynthesis, but here look at, this is a carbon skeleton is present over there. Sometime it is clearly apparent, sometime it is partially apparent, and sometime it is hidden in that. So you have to find out and try to find out its chiral, and this is a chiral template. Chiral template means where it must be that compound is optically active in nature. So that type of the starting material or the precursor is known as chiral template, where the Chiron framework is exactly similar to the symmetry, as well as whatever chiral center is there, they are remains or exactly that segment is similar to, and stereochemistry also similar to the starting material. That thing is known as a chiral template, right? And now this chiron may activate here, and you will get as this type of the acyclic equivalent over there, and you try to bring together, assemble together, and you can synthesize that compound which is the target molecule which is medicinally useful. So this is a synthetic design with chiral templates, and the generation of chirons, how it is obtained over there. So that is generalization thing we have seen over here. That is arbitrarily, and where whenever applicable, the chiron contains the highest level of functionalization and stereochemical overlap with the target, yet it maintains the basic carbohydrate structure, and such as a cyclic or the acyclic derivative. And beyond that stage, a chiron may no longer resemble a carbohydrate, and in a visual sense it could be lose formal structural ties with the precursor from which it was derived. And the format of presentation in this book is therefore intended to show how to locate possible carbohydrate like symmetry in a given molecular target, how to effectively disconnect contain precursor and eventually to a carbohydrate progenitor, and finally how to utilize the latter for the reverse process, that is the construction of critical intermediate chirons and eventually the target structure itself. And with this type of presentation, the contribution and the structure, stereochemistry of the starting carbohydrate is its derivative is the considered to be secondary character and a matter of operational convenience. And in order to indoctrinate the reader to such a philosophy of linking at molecule and engaging in a visual dialogue, it will be helpful to establish some general guidelines. And the concept of retrosynthetic or anti-synthetic analysis of a target structure is pictorially and operationally useful in this approach, and it will be systematically used for figure shown below illustrated how the chiron is derived from the target by retrosynthetic analysis and produced from the chiral precursor template via synthetic operation, which is shown now here. Better representation. Let us see here that also is belonging, how we are getting as a chiron over here in a more generalized form. Let us see here. Suppose we have this one simplest way of representing, that is suppose let us consider, suppose this is our target, right? This is our target. Look at, I am shading this. This is our target. Let us see. This is our target in the simplest example. This is our target. Now, and after using as a retrosynthetic approach, what do you get here? Let us see here. This one, this part. So again I am showing the shaded arrow only, shaded portion of this. And now this is called as a chiron, because this is apparent in the target molecule, whatever segment, exact copy of that segment which is present already in the target. And now this, and as we know that a Chiron template means all this part over there is called as a Chiron templates. So here maybe as a this type of they may present in different forms. That type of the thing is called as a that are the template over there, right? This is called as a chiral templates. These are known as chiral templates, or we can call it as a precursors. This is a precursor, means we can break from here or here, this type of the four portion you join together, that is known as a chiral template. And that chiral template systematically, by keeping the stereochemical or stereo controlled functionality overlapping over there, and we are getting as a chiron, and chiron, from that we will get our desired target molecule. That is a systematic representation of the chiral approach. This one, if you from this to this, if you do synthesis, this is a synthesis from chiron approach. Whatever synthesis, that is called as assembled over there, right? Assembly means we assemble together, we are getting as a target molecule. And from systematic modification, and this chiral template require the systematic modification. After doing the systematic modification, we will get the chiron over there, and once you get the chiron and synthesize it by keeping all the reaction condition, and you will get your desired target molecule. So this is a systematic representation of the chiron approach. So I think there and now the how to look behind this, how to show that chiralities or the target molecule. See, types of target derived from carbohydrate precursor by synthesis, and in considering the types of target structure that can be constructed totally or in part using carbohydrate precursors, there emerge three general categories. There are three general categories by looking this one. First one, apparent carbohydrate type symmetry. Apparent carbohydrate type symmetry, you have to look into that. The carbohydrate portion in such a target is apparent and can be singled out, and this category include a large number of compounds that comprise chiral tetrahydrofuran and tetrahydropyran structure, such as the polyether antibiotics, certain terpenes, metabolites, toxins, C nucleosides, cascade produced derived from arachidonic acid, pheromones and insect poisons, and also include monocyclic and bicyclic lactones and a number of simple cyclic structure. And it is evident that in a synthetic strategy aimed at such target, a suitable cyclic or acyclic carbohydrate derivative can be utilized to achieve the desired level of stereochemical convergence with the targets. And the term acyclic and cyclic transfer of chirality have been used for faster rate. A partial list of such target have been reported in a previous review. And second one is a partially hidden carbohydrate symmetry. In some cases there is a partially hidden carbohydrate symmetry are present, but you have to approach that way. The carbohydrate portion in such a target is only partially evident and may constitute an extension of the total structure. And certain amino acids, terpenes, various cyclic and acyclic compound are structure containing a cyclic chiral appendages. Among these may be considered to belong to this category. Such molecules may be constructed by chain extension or ring formation using one or more carbon atoms or appropriate carbohydrate precursor, and after the desired level of chiral and functional overlap has been achieved. And now the last one is the third one, the hidden carbohydrate type symmetry. The carbohydrate portion, such a target is not evident and must be located. First, it may constitute a segment containing one or more chiral center in a more complex structural framework bearing number of formal resemblance to a carbohydrate. Examples in the category are more challenging in terms of design, discovery and execution, and it is here when loss expected based on past lack of operational directive that the utilization of carbohydrates on chiral building block emerge as a variable and the viable and practical strategy. The concept of chiral templates and the generation of chirons by retrosynthetic analysis add a new dimension to a natural product synthesis. Based on this approach, alkaloids, macrolides, prostaglandins and heterocycles, to mention a few, are likely target as already illustrated in a partial list, and the term transcription of chirality has been used by this carbohydrate symmetry in the three categories illustrated below. Suppose here let us see those whatever symmetries we have seen. One is a apparent symmetry found in the carbohydrate that diagrammatically shown over here. Suppose we have this type of the structure like this. Here maybe as a Y substituent present over here and the X substituent present over here, and this one is given CO2H, their OH, and here is HO. This is the symmetry present over here. Here is apparent. Apparent means we can see clearly, we can recognize there is a hydroxy group are there, carboxylic acids over there, and therefore it is present over there. So partially hidden maybe as this type of the structure, partially hidden structure. You can suppose we have this one structure and then OH here and the X may be here, that is a partially hidden. This is shown as a partially hidden carbohydrates. We cannot identify exactly. And then last one, this type of the here the maybe as a this one dot is there, then y, and here is a z, and here is a x you can write over there. So this is a hidden, we cannot easily, only those can look that particular way, they can immediately find out this type of the things over there. I think with this we have seen this type of the terminology. Again, chiral templates and the chiron, what does it means, that are the things we just now seen. Let us again repeat that main terms. What is that? That is a what we can call it as a template, chiral templates and the chirons. Again, chiron templates and the chiron target molecules, how it is obtained, and the carbon framework, which are an exact copy of the segment of target and have its inherent natural chirality, which can be related to original stereochemical part of the target, are called as a chiral template. I think with this, let us stop today here. Remaining we will see in the next lecture. Thank you. Have a nice day.